How to expand a fraction. So we got 3/4. So 3/4 equals 3/4. Okay, that's what we call the identity element or reflexivity. There's a lot of math things that say this is true. Okay, but now we're going to take the fact that multiplying any number by 1 doesn't change the value, right? So 3/4 times 1 is still 3/4. But now there's an infinite number of ways to represent the number 1, especially with fractions. So 1 is the same as 2 over 2. Okay? And if we multiply 3 by 2, we get 6 on the top, and the 4 times the 2, and we get 8 on the bottom. Right? The top number is the numerator, bottom number is the denominator. But that 6/8 is still equal to 3/4, right? They're equivalent fractions. I could do it again, right? 1 is still represented as a 3 over 3, but then I get a different fraction, 9 over 12, but it is equal to 3/4, right? I could do this forever. As long as the numerator and the denominator are the same number, I could expand 3/4 into an infinite number of equivalent fractions, even -7, right? -21 over -28, when you reduce it, is 3/4. So any number divided by itself, except for one number, 0. 0 divided by 0, we don't know what that is. We assume it's 1, but it's not 1, so we can't prove it. So x can be any number except for 0, such that when you multiply by the numerator and the denominator, it's simply gonna just expand 3/4. That's what we're trying to say. So why do we do that? Why do we expand fractions? We use them to create an equivalent fraction that has the same value, but with a different common denominator, such that we can go ahead and add and subtract fractions, because that's the main rule with adding or subtracting fractions, is that you can't do that until they have the same denominator. And that's it. MGZ out.